Alrighty, how you guys doing? This is going to be the lesson. We went over this for today, so if you missed today, today is September the 15th, 2020, and what we're going over is section 1, topic 3. Again, this is section 1, topic 3. We started off with the warm-up. The warm-up was to write the following numbers as a fraction or as a decimal. So in order to write these numbers as a fraction or a decimal, 3 can be written as 3 over 1. You can also write this as 300 over 100. Another way of writing as a fraction is you could say negative 18 over negative 6. You can also say negative 48, or I would say positive 48 over 16. You can also write it as a decimal, as 3.00, or you can also write it as a really long decimal, 3.000000. Negative 15. If you had to write negative 15 as a fraction, you can say that negative 15 is the same thing as negative 15 over 1. You can say that this is negative 45 or positive 45 over negative 3. We can also say this is a negative 15,000 over 1,000. This is also the same thing as saying negative 15.00 or negative 15.000000. So I'm preparing you for what we're talking about, which is rational and irrational numbers. Okay, these fractions that we have, you'll see that how we define those, and you'll see how this warm-up goes into play with the whole lesson. Okay, the next part told you to calculate the following numerical expressions. Negative 5 over 8. This is the same thing as saying negative 0.625. 7 over 3 is the same thing as saying 2.33. And that's going to repeat. 0 over 2,532. That's just 0. Negative 319 over 0. If you type it into the calculator, you're going to get an error message, which means that it is undefined. We write UND, undefined. And the reason why is because your denominator can never be 0. Okay? You can have 0 as your numerator, but it cannot be in the denominator. Okay? All right, so let's get to the lesson. So, lesson is titled Section 1, Topic 3. A rational number. Okay? A rational number is any number that can be written as A over B, where B is not equal to 0. Okay? And remember, B is in the denominator part, and the reason why B cannot be 0 is because that's going to be an undefined number. Okay? But here's the main thing, is that A and B are integers. Okay? Understand that integers are just your natural numbers and their opposites. So it's negative 1, negative 2, negative 3, negative 4, negative 10, negative 13, negative 1,887, negative 1 million, And it's also all your positive numbers as well, and zero. So it's 1, 2, 3, 4, 5. It's 10. It's 22. It's 300,000. 703. It's 5 million. So it's all the numbers combined together. So as long as the top and the bottom number are integers, then you have what is called a rational number. Another way to say that something is a rational number is that if the number can be written as a terminating or a repeating decimal. Okay, a terminating or a repeating decimal. For instance, in our warm-up, we had -5/8, and we noticed that when we had that, our answer was -0.625. Nothing came after the 5 in the decimal, so this is what we will call a terminating decimal. Okay, terminating decimal. When we had the 7.3, this one was equal to 2.3333, and that kept repeating. So that is what we will call a repeating decimal. Either way, both of those are what we classify as a rational number. Okay, rational number. 75/25. That is equal to 3. Okay. Square root of 9, that's also equal to 3 as well. So with the 3, you can write 3 as a fraction because 3, like in the warm-up, can be written as 3/1. So these are all examples of rational numbers. Okay, these are all examples of rational numbers. If a number cannot be written as a fraction or as a terminating or repeating decimal, then that number is classified as an irrational number. Okay? Irrational. So if you have a calculator and I asked you to do the square root of 2, what would you get for that? Okay? So the square root of 2 is 1.41412356237, and it's going to keep going on and on and on, right? The cube root of 9, the cube root of 9. So this is not the square root of 9, this is the cube root of 9. Okay, or the third root of 9. And that is going to be equal to 2.08008382305, and that's going to keep going on and on as well. If you look at these two numbers, the square root of 2 and this cube root of 9, and you see what they have, these are very long, exaggerated type of numbers. Kind of like a person. So when you think of irrational numbers, think of a person who's being irrational. A person who's being irrational takes a long way to kind of explain something. Or it seems kind of crazy. Okay? So these numbers look a little crazy. They don't seem as simple and short and sweet. Okay? So irrational numbers are numbers that have a decimal that does not have a repeating pattern, and it does not end. Okay, so that's how you can tell the difference between an irrational and a rational. A rational number seems very short and sweet, but in a grand scheme of things, or just to go with the definition, a rational number is still any number you can write as a fraction. Okay, or it has a terminating or repeating decimal. Right. So let's go with these right here. It says classify the following numbers as a rational or irrational. Use your calculator for assistance. Square root of 9. Square root of 9 is going to be 3. So in that case, this is going to be a rational number. Square root of 8 is going to be a very long number, right? It's going to be like 2.8 something. Let me get my calculator out. Square root of 8 is like 2.828427142, and it keeps going on further than that. So this one, we classify this one as an irrational number. Okay. If you type in the number pi is 3.1415926, and it keeps going on further than that one. So this one is classified as irrational. E, okay? E is 2.7182818, and it keeps going further than that. So this one is irrational as well. (33 over 2). 33 over 2. Well, this is a fraction. Not only is it a fraction, but it's a fraction where the numerator and the denominator are integers. So just like the definition, okay? The definition says that they have to be integers, okay? And the bottom part cannot be 0. So in this case, 33 over 2 is rational. (9.488888888). This is a decimal that has a repeating part, and it does end after the fifth 8. So this one is rational. (-25), you can write that as (-25 over 1). Both of those are integers, so therefore this one is a rational number as well. 22 over 7. 22 over 7. This was a trick one for some students because they typed it into the calculator and they got a very long number that didn't have any repeating decimals, but it's still a fraction. Right? It's still a fraction, so this one is rational. That one is rational. So this is how you classify the difference between a rational and an irrational. Okay? Again, your irrational numbers have a very long, non-repeating decimal that doesn't end, and your rationals are numbers that you can write as a fraction or as a terminating decimal. How you doing? I think that's the camera. Oh, hold on, let me pause it right quick.
I think this is the camera. Why this one? You don't have another camera, right? Oh, sorry.
No, that's the only one.
That's odd. This is 5304, right?
Yes.
So I'm just gonna update this by day.
Thank you. No problem. All right. So sorry about that, everybody. Let me go back to the screen that we had. I'm so sorry.